So, lesson 3.3, logs. Logs we're going to kind of be dealing with, I think, the rest of the chapter pretty much. Maybe not 3.6. I don't remember if it's in 3.6 or not, but we're dealing with logs for the next several lessons. Okay? Do you remember anything from logs last year?
Yes. That I wasn't there.
Okay. Well, they're back. Okay. I will tell you, they are something that we have to work with. When we go into more of our trig semester next semester, we're not going to really see logs a ton. They do come up in calculus. Okay. In fact, one of the things that I've had to do is I printed off a paper of log rules for my calc kids because we've got to make sure we go back and remember them. So, okay. So, logarithms. Okay. Logarithms of the form log base b of x equals y. Remember, when we work with logs, a lot of times when we work with logs, we don't actually work with the logs. We change it to an exponential form. Okay, so remembering that this log form is equivalent to b to the y equals x. Okay, so log base b of x equals y is equivalent to b to the y equals x. You remember it your way. If you ask me, my phrase to help you remember is going to be left, right, middle. So the base on the left raised to the y on the right equals the x in the middle. So there is my left, right, middle. So b to the y equals x. Okay? So we're going to work with a lot of different pieces here. Evaluate the following logs. Okay? Well, first of all, it doesn't tell me to use a calculator, so we're not using a calculator. Okay? There will be some, it's farther on down the page, where it says evaluate using a calculator, but these actually can't be done on a traditional calculator anyways. Because, what bases are they? Base 2, 3, 5, 4, 7. Okay? That traditional log button on the calculator just does log base 10, which we'll talk about down here when we talk about common logs. So we have to have other ways to work these. So, log base 2 of 8. I want to know what that's equivalent to. My suggestion is that you set it equal to a variable. I'm using y, so it kind of resembles the problem up above. So our job is to find y. How can I write this in another form to find y?
2 y. Or like the y up there. When it equals 8.
Okay. So left, right, middle. The base of 2 raised to the power of y equal to the 8 in the middle. Now, we're trying to find y, which is an exponent. What do you know about 8?
It's 2 cubed.
It's 2 cubed?
Yeah.
Our goal here is to get like bases. Can 8 be rewritten with a base of 2? It can. Okay, so that was a weird y. 2 to the y is equivalent to 2 to the third. If 2 to the y equals 2 to the third, what's y?
3.
Y is 3. If the bases are the same, the powers have to be the same if they're equal. So log base 2 of 8 is equal to 3. This is one way to evaluate these logs. Once we talk about properties, we'll talk about some other ways to do this. But this is one option. So let's keep practicing some others. Log base 3 of the square root of 3. Well, I'm going to suggest we make this log equal to y.
3 to the y is equal to the square root of 3.
Okay. 3 to the y is equal to the square root of 3. So the common question is going to be, can we make those bases the same? What do you know about the square root of 3?
3 to the 1/2, right?
You remember that? Radicals, square roots, can be written as fraction exponents. And so since this is a square root of 3 to the first, that is equivalent to saying 3 to the 1/2. And if 3 to the y equals 3 to the 1/2, then we know y is 1/2. Good enough? Okay. C. Log base 5 of 1/25. I'm going to set equal to y. What's the equation we can write? Left, right, middle. 5 to the power of y equals 1/25. Thoughts on 1/25?
-2.
Okay. And if it helps, what do you know about 25 as a starter step? 25 is 5 squared. So if you think of this as 1 over 25 is 5 squared, then that is the same as saying 5 to the, how do we get the power out of the denominator? To move it across the fraction bar, you make it negative. So negative exponents represent those powers in the denominators. So 5 to the y equals 5 to the negative second, then y is -2. Okay. D. Log base 4 of 1 equals, I'm going to set equal to y so we can find y. How are we going to rewrite this? 4 to the y equals 1. Anything raised to the 0 power is equal to 1. So if you want, I mean, I agree. You can just say y equals 0. But if you want a step in between, 4 to the y, well, 1 can be rewritten as 4 to the 0, yes? So there's me showing you the bases are the same. Not that you would have to go that step, but anything raised to 0 power is 1. We've talked about that lately, haven't we? Okay, one more, and we're going to learn some properties. Log base 7 of 7 equals y. And once we learn properties, a couple of these you wouldn't have to do any work on. You just look at them and know. Like this one, I know what it is without doing any work. But that's because I know the property. If we do our left, right, middle, what do we have? 7 to the y equals 7. So what is y? 1, right? Because 7 to the y is technically equal to 7 to the first. So y equals 1. Okay, guys. In all honesty, this is kind of a long way on some of these. Okay? However, it's a way that always works. Okay? Take that log, set it equal to a variable, rework your left, right, middle, and see what you can do with it. Right here, we have 4 properties of logs. In several of these cases, had we known, we wouldn't have to do any work. Okay? Log base b just means it could be any base. Okay? 3, 4, 5, 21, 32, any base. So log of any base of 1 is always equal to 0. Guess what? Part D, log base 4 of 1, automatically it's a log of 1, so automatically it would be 0. So that's property 1. It's just a property to memorize, to know. It'll make life quicker. 2, log base b of b is equal to 1. So what this is saying is that when your base matches the inside of the log, when the b's match, that log will always equal 1. Well, that's example E. Log base 7 of 7, guess what it equaled? 1. Okay. Kind of a mix off of this. Log base b of b to the y is going to equal y. And it kind of works off of the other one. But the idea is if the base of the log is the same as the base of the inside. In this case, then your answer is equal to the exponent. You could technically consider this the same one. Log base b of b to the first power is equal to 1. Okay, so when the bases are the same, it's always equal to the exponent. That power or that property would have technically worked on A, B, and C. Because all of those this could be rewritten as log base 2 of 2 to the third. So that property could have worked on A, B, and C. And then we haven't talked about anything like property 4 yet today, but base B raised to the power of log that is also base B is equal to y. So that's saying that if you have a base of B raised to a power that has a log the same base, your answer is going to be equal to the y value. Okay, and that's as long as those b's match. So those are 4 properties to become familiar with. They can speed things up. And this is, I mean, some of these you're just going to look at and know the answers, which is part of the reason that I can assign 40 problems. Okay? So let's look at A. Log base 3 of 27. If we did this up above, we'd set it equal to y and do a left, right, middle. I want to use our properties. Or, excuse me, laws of logarithms, whichever way you want to say it. What do you know about 27? And here's what I'm looking at. It's divisible by 3. If this base is 3 here, I'm guessing 27 can be written as a power of 3. That's what I would suggest you guys think. I mean, I know it can, but my suggestion is when you see log base 3, ask yourself, log base 3 of 3, can I rewrite 27 as 3 to some power? What is 27? 3 to the third, right? 3 times 3 is 9, times 3 is 27. So I now have log base 3 of 3 to the third. What is this equal to?
3.
Now, which 3 is it equal to? Why 3?
Y, the top one.
Okay. These 3's match. So since those 3's match, the exponent is my answer. Does that make sense?
Is it wrong to write y equals 3 still?
There's no y in the problem, so it's not wrong, it's just not necessary. Does that make sense?
Yeah.
So. Okay. What about B? Can you do something with B?
1/2.
He says 1/2. No work, no nothing?
No.
Just 1/2.
Yep.
Do we see it?
Yeah.
Because I can rewrite this as log base 2 of 2 to the 1/2 power. Agreed? And that means my answer is the exponent, and the exponent is 1/2. This is why some of the 40 problems will go quick, right? That's why I said don't complain until you see what some of your homework will be. Okay, C. Log base 25 of 25.
1.
1? That is property 2, yes? 25's match, so it's equal to 1. D.
7.
He says 7.
Okay.
This is property 4. When this base 6 matches the base of my logs, and so 6's match, my answer is the 7 that's the inside of the log. And log base 8 of 1.
0.
0. This is property 1. Anytime it's log of 1, doesn't matter the base, it will always be 0. Okay, you got some basics there? Okay. Keep those properties in mind. We're going to use them as we go forward. Now, officially, what we were just talking about was logarithms. Okay? With that in mind, we had a variety of bases. Specifically, when you hear the word common logs, okay, when we talk about common logarithms are specifically the logarithms that are log base 10. Now, what is important about that is that When you see a log written without a calculator, what do you automatically have to know? I just said a log without a calculator, didn't I? When you see a log written without a base, what do you automatically have to know? It's base 10. Okay? Any other log will have the base written in. Except if there's no log written, we know it's base 10. Okay?
Wow.
Okay. Okay, so this also means, folks, what's the log button on your on a calculator do?
10.
It's base 10. Huh? Automatically base 10, okay? So, evaluate the following now. Did you catch the directions here? Without a calculator. This is not grabbing your calculator and typing it in. This is how do we do these logs without a calculator. So this is, we're still using our properties. So thoughts about log of 100 without plugging it into your calculator.
No. It'd be 10. Yep. It's 10. Oh, it is 10 to the 7. Oh, me too, right?
So this is log base 10. What do you know about 100 that's important?
It's yeah.
I thought I heard someone say it.
Yeah, 10.
100 is 10 times 10,
Yep.
which is 10 squared. Are you there?
Yes.
Now, why is that important? It's log base 10 of 10 squared. What do our properties say this is equal to?
2.
2. Are we all caught up?
Yeah.
Minus Jaren, who's going to take a moment to catch up here. Okay, so remember the property. If the base of the log and the inside of the log are the same, it's equal to the exponent. Okay. What about B? The log of the fifth root of 10.
Yep.
Can we see a 1/5 in there? And again, there's no base written, so what base do we know it is? That's log base 10. And that's going to be, how do we write a fifth root? That's a power of 1/5, right? So if it's log base 10 of 10 to the 1/5, this is equal to 1/5. If you notice, these are kind of mimicking our first row of examples we did up there. Actually, the first row of examples. We had one with a power, we had one with a radical. Now we have one with our fraction. 1/1000. Log of 1/1000.
Minus
Negative
3.
3.
Okay, and here's the deal. What do you know about 1,000? 1,000 is 10 to the third, yes? So if I rewrite this, this is log base 10 of 10 to the negative 3, because the negative 3 is taking me out of the denominator. And so since the 10s match, this log is equal to the power, which is negative 3. Okay? D, 10 raised to the log of 6.
6.
Because what is the power of that, or what is the base of that log?
10.
The base of that log is 10. And if these 10s match, that means my answer is equal to 6. That's that property 4 up above, right? The base and the log base match, it's equal to 6. E,
0.
log of 1, no matter the base, is always 0. I'm going to write a 10 in here, but honestly, it doesn't matter. Now, could you have taken any of these and punched them into your calculator and gotten the same answer? You could. Okay, you have that as a check. But I want you to be able to do these without the calculator. Now, what do you notice about the next row?
Calculator.
Okay. Grab your calculator. And really more than anything, this is about knowing where the log button is on the calculator? I mean, you know. So grab your calculator, and everyone get an answer. If you don't have your calculator, grab one of my calculators. Where is the log button? See, this is why we're talking about it right now.
Yeah, go ahead. Anybody else while I'm up?
What are we rounding to?
Here you go, Goob.
I believe 3.
Okay.
Yeah. Okay, so this is, now, why can I do this on the calculator? Because it's log base 10.
And
You've got,
other,
my log button is right next to my 7. And other than that, it's really not difficult. The difficult part is knowing where is the log button, right?
Oh, never mind.
I have my answer key to 3 decimal places, which if I had to guess, that might be what homework is. So log of 34.5 is approximately what? .538. If we're going to the nearest thousands. Okay? B.
Y equals negative 0.367.
Okay. This is negative 0.367.
Either I did something wrong.
Now. Why is it negative? Why would you guess it's a negative answer?
It's less than 1.
Okay. And there is that connection. You're just doing a basic log. If it's a number bigger than 1, you're going to get a positive answer. If it's a number less than 1, you're going to get a negative answer. What about log of negative 3?
No answer.
Okay. You're getting an error of some sort, right? Officially, I'm going to write this as undefined.
I was trying to guess what
Kind of equivalent to no solution, but I'm writing it as undefined. And why is it undefined? Why can't we do it? It's a negative. Now, here's my reference. I know if I say, okay, what's the log graph look like from less than 1.3? You guys are going to give me this deer in the headlight look of, I don't remember what the log graph looks like. So I'm going to tell you. The log graph was the graph. So exponential graph was up here. Okay? Log graph does something like this. And the traditional log graph will cut through the x-axis at 1. Now, with that in mind, so anything that is above 1, notice I'm going to get any x value input that's above 1, I'm going to get a positive answer. Anything between 0 and 1, my graph is negative. I'm getting a negative answer. What about any x values negative? Does my graph exist to the left of the y-axis? No, the graph doesn't exist over here. Since the graph doesn't exist, I can't have an answer. If we want to talk domain, the domain of this graph is just 0 to infinity. So it's not going to, I can't have negative values there. Okay? So we can only use positive real numbers to do this. Okay. Questions at this point? Okay. Example 5 then. Officially, this is solving some basic logarithmic equations. I will say lesson 3.5, we do a lot of equation solving. This one, these are more basic. But solve simple logarithmic equations. And notice it says by changing to exponential form. As we look at A, log of x equals 3. Can I do anything with it in that form? No. So how do we change to exponential form? What am I going to tell you to do? Yeah, to get it out of log form into exponential form, left, right, middle. Anytime you see me write LRM, realize I'm saying left, right, middle. Okay? I feel like we talked about LRM last year. I feel like that came up at some point last year. So, log of x equals 3. Thoughts then?
10 to the 30.
Okay, there's no base written. So automatically we know no base. It's going to be base 10, left, right, middle. The base on the left raised to the power on the right equals the x in the middle. Well, this solving is really easy, isn't it? 10 to the third equals x. So what is x?
10 to the third.
And what is 10 to the third?
X.
I'm looking for 1,000.
Okay.
I'm not saying what you're saying is not true, but not what I was looking for. Okay. What about B? Okay, this time we have a base other than 10, yes. So the base of 2 on the left raised to the 5 on the right is equal to x in the middle. Again, do I have any solving? I don't. So what is x? 2 to the 5th is 32. Okay. Thoughts on how to solve C?
3 to the x.
Okay. Can we take this in the same form? Change it to exponential form, left, right, middle. So 3 to the x equals 1/9. 1/9 is 1 over 3 squared. 3 squared, to get it out of the denominator, is 3 to the -2, yes? If you need that intermediate step to say 1 over 3 squared, then do that. But then we find that x is -2. Now, I have a question before I move on from that one. Is there another way I could have done that? I mean, I guess it's obvious if I'm asking. And I know, I suggested left, right, middle. We used left, right, middle. We had to use left, right, middle on A and B. This just says this log equals x. Could you rewrite this log here?
Yes.
In other words, could we basically use one of our laws there? That, it's not going to let me write there. The log of base 3 of 1/9 is 3 to the -2nd. Could we have looked at it in that idea? And using our, just taking this log, rewriting it, log base 3 of 3 to the -2nd is the -2. Okay, you could have used your law there. Did you need to? No. Left, right, middle was fine as well. Okay, what about D?
X to the third.
Okay, left, right, middle. X to the third equals 64. She says 4. Do you like it? How did you get 4?
4 to the third.
Okay. So one option is x to the third. If I take 64, it is 4 to the third. X equals 4. Can we also talk about the cube root? So cube root of x cubed equals the cube root of 64. Okay? It's possible both ways there, isn't it? Do I need plus or minus?
No.
No, because it's a cube root. We took the cube root. If we had taken a square root, would we need to consider at least plus or minus?
Yeah.
We'd at least need to consider it. Now, keep in mind,
Can't you have a negative base?
I don't think so.
Because, for this, you're solving for the base instead of,
Yeah. I don't think you can have a negative base.
Okay.
I'm trying to,
So then,
yeah. So,
matter if you did plus or minus? Or?
well, technically you should consider plus or minus because it could matter in some situations. In this one, it would. Okay. Okay. We talked about logs, any base. We talked about logs, common logs, which are logs base 10. What we have not talked about are natural logs. Okay? Natural logs are logs that are base E. Okay? So, natural logs are logs that are base E. It's just kind of like a common log. You don't write the base E. So, if you see the LN, which stands for natural log, it is just that. It is natural log. Now, the first row says to evaluate without a calculator. Do my log rules still apply? They do. Okay. So, natural log of the square root of E. What do you know about the square root of E? It's E to the 1/2. What base is natural log?
10.
E. So if it's base E, and it's E to some power, what is this equal to? 1/2, right? This is what, rule 2 or something from the front side? Are we okay with that? Okay, I feel like B probably should have been first. What's the natural log of E to the 5th? 5? Because this is base E. What's E raised to the power of the natural log of 4? 4, because what base is this? E, the E's match, so my answer is 4. Now, calculator. What do you do on the calculator now? You find a different button, don't you? It's usually right near your log button. Is it there somewhere? Right below. Okay. Now, what kind of answer do you expect to get on the first one? Positive, negative, or no solution? Positive, because we're doing the log of a number bigger than 1. What do you get?
3.157.
Approximately 3.157. What about the natural log of 0.48? I'm going to expect this answer to be what? Negative.
No, I'm just kidding.
You left off the 7 the first time and confused me. 7, negative 0.734. C, do it without a calculator. Because
It's a negative.
I can't do the natural log of a negative. Okay. Tomorrow, I'm going to finish the bottom. And you're going to have, which the bottom's going to take me a moment. It's going to be probably one of the longer parts of the lesson. So we're going to look at some of these graphs and translations. And then I'll give you some work time on your 40 problems.
Okay. Do Friday.
So that does make them due Friday. Okay?
Ow.